I'm Sig Hossiger. I'm the manager of the Andritz laboratory at Andritz Separation Inc. in Arlington, Texas. Welcome to our lab.
When a client sample arrives at our applications laboratory, it is tested for general characteristics using various filtration simulation systems to help determine the best separation solutions for our clients. The pH level is measured to determine the degree of acidity or alkalinity. The electrode is removed from the baseline buffer solution and immersed in the sample. The reading should be within 1/10 pH unit of the baseline buffer. A small amount of testing sample is poured into the cylinder on a sheet of chromatography paper. The paper extracts liquid from the sludge by capillary action. The results can be used to assist in sludge dewatering processes, to evaluate sludge conditioning aids and dosages. The specific gravity of a sludge sample is determined by comparing the mass of a known volume of homogeneous sludge sample at a specific temperature to the mass of a same volume of distilled water. The sludge volume index is used to monitor settling characteristics of activated sludge and other biological suspensions. It is the volume occupied by 1 gram of suspended solids after a 30-minute settling period. To measure total solids, a well-mixed slurry sample is evaporated in a pre-weighed dish and dried to a constant weight in an oven at 103 to 105 degrees centigrade. The increase in weight over that of the empty dish represents the total dissolved and suspended solids present in the sample. A well-mixed sample is filtered through a weighed standard glass fiber filter. The residue, retained on the filter, is dried to a constant weight at 103 to 105 degrees centigrade. The increase in weight of the filter represents the total suspended solids. A sieve analysis starts by weighing a portion of the test sample. Stack 30, 50, 100, 140, 230, and 325 mesh sieves in order. Wash the pre-weighed sludge sample from the uppermost screen to the next screen according to the stacked order. Continue the process until all 6 screens have been thoroughly washed. Filter the retinate on a tiered filter paper using a vacuum-assisted Buckner funnel from each screen, and dry the filter paper in an oven at 103 to 105 degrees centigrade. Weights recorded and tabulated during the procedure are initial sample weight, tare weights of filter papers, final dry weight of filter paper, and percentage retained on each screen. Polymers must be diluted with water before using them to chemically condition prior to filtration. Prepare all solutions on the test day. Polymer is added to water at the desired concentration. The water should be mixed with a mechanical propeller type mixer to develop a good vortex. Add polymer slowly to the vortex. Syringe should not touch the water. Mix for 15 minutes, maintaining a good vortex. Examine the solution for solubility and polymer accumulation on the mixer. No chunks of polymer should settle to the bottom of the beaker. Finish mixing for approximately 15 minutes. Age for 20 to 40 minutes before using. polymer is incrementally added to 200 milliliters of sludge and thoroughly mixed. Sludge can be conditioned with various dosages of polymer using an overhead stirrer or beaker-to-beaker mixing called the boxing method. The amount of mixing needed to reach optimum conditioning varies with different polymers and sludge concentrations. Sometimes, in order to maintain optimum conditioning, you will have to vary the amount of mixing with the polymer dosage. If no flocculation occurs, then more polymer is added and mixed. Polymer is added again until a definitive flock has formed with a clear liquid. After these tests, the polymer that gives the best drainage at the optimum dosage can then be subjected to dewatering or thickening testing. The drainage curve test is conducted by adding flocculated sludge to a funnel to watch the characteristics of the drain. After preparing sample and drainage curve apparatus for testing and entering the sample volume, total solids, dilution water volume, polymer volume in the drainage curve sheet, pour sample onto fabric in the funnel of the static Thickener drainage curve apparatus. When using a computer and spreadsheet for data collection, make sure data is being displayed correctly on the spreadsheet and new numbers are added down the columns. By representing this process at different flow rates, it is possible to develop a curve showing the relationship between outlet solids concentration and flow rate. After the test sample volume has been determined, it is appropriately flocculated and gravity drained in the wedge box. This is lined with a polyester filter fabric which conforms tightly to the shape of the box in order to retain the sludge solids. Flocculated sample is poured into box. A spatula is used to simulate the rolling action applied by the plows in the gravity zone. The time for the gravity zone and wedge zone is determined from the belt speed and the dimensions of the belt filter press being simulated. After the gravity zone is reached, a second filter fabric and a pressure platen is added on top of the thickened sludge. The pneumatic ram is engaged and apparatus is inverted to simulate the wedge zone. After the wedge zone time is reached, the apparatus is returned to upright position and then the pneumatic ram disengaged. The cake is then removed from the box and placed on a larger filter fabric. A cake sample that has been placed on a filter fabric is then placed into the S-roll section simulator. The belt speed and belt tension is adjusted during the test to match the belt filter press being simulated. Cake height is measured and samples taken for solids analysis.
Take it out of frame.
The sample is flocculated and shear tested with a 1-liter bottle to determine if the flocculation would withstand the forces entering a decanter centrifuge. Additional polymer may be required beyond jar testing. Centrifuge spin-down testing consists of 2 parts. The first part is centrifuge tubes with and without polymer. The spin tube test determines if and how well the sample will settle under centrifugation. The second part is to determine the cake dryness achievable. The flocculated sample from shear testing is thickened over a filter fabric. The screen tubes are then filled with the thickened solids. The screen tubes allow simulation of the beach or incline section of the centrifuge. The tubes and screen tubes are placed in the laboratory centrifuge at the desired G-force and set at varying spin times. To simulate the action inside a full-scale decanter, the cake inside the screen tubes is stirred up and rolled over every 5 minutes. After centrifugation, the solids in the tubes and screen tubes are removed for solids analysis. The Andritz sludge resistance meter is a stainless steel sealed vessel which is pressurized by a regulated supply of bottled nitrogen gas or air. To simulate a recessed plate filter press, a known sample volume is poured into the vessel. The pressure forces filtrate through the solids, which are retained by a filter cloth. To simulate a membrane plate filter press, the piston applies pressure to the top of a known sample volume inside the vessel. The pressure forces filtrate through the solids, which are retained by a filter cloth. The filtrate's cumulative volume versus time is measured for both the recessed and membrane plate simulation. Cake forms as the filtrate passes through the filter cloth. The cake formed in the resistance test is evaluated for consistency and release quality from the filter media, as well as varying applied pressure, filter cloth type, and cycle time. A sludge or slurry can also be tested at varied temperatures. To determine the size for a high-rate thickener, the settling rate must be determined. The sample is mixed and the solids level is marked at 10-second intervals for the first minute, and then at 1.5 minutes, 2, 3, and 5 minutes afterwards. The solid's settling rate is then converted to meters per hour, or feet per minute. This test can be conducted with different flocculants and dosage rates to determine the settling rates with the addition of flocculant. The solution is stirred overnight, and the next day the liquid is poured out and the solids are measured. Horizontal vacuum belt filter is tested with a modified Buckner funnel to allow a filter fabric to be used. A sample is poured into the Buckner funnel and vacuum applied. Time is recorded then when the vacuum is turned off to the Buckner funnel. The time from the cake formation time to this point is the cake dry time. Varying sample amounts and cake dry times should be tested to determine the optimum operation and sizing for a full-scale horizontal vacuum belt filter.